Hey guys, how are y'all today? So here we're going to start Unit 2, kind of the biochem. We'll take this all the way through cells, all the way to organelles, and hopefully through down to mitosis before we get out for term 1 break. All right, so we're going to start with biochem. Like I said, biochemistry is just the study of the structures and the composition, aka what things are made of, and the chemical reactions that occur in, keyword, living things. Because once again, this is bio. Okay. So in chemistry next year, you'll be talking much more about inorganic chemistry. Right now, we're going to be dealing with organic-y things. All right. So let's talk a little bit about what makes up atoms. So atoms are everything on Earth, everything even in outer space, is made up of matter. All right. Matter is anything that takes up space, aka volume, and has a mass. Now, this mass can be very, very tiny, like in the form of electrons, but it needs to have mass altogether. All right. Mass is made up of a small unit. This is called an atom. Atoms are made up of 3 subatomic particles. Subatomic just means below atoms. You will need to know these and their charges. Protons plus, electrons negative, neutrons no charge. So the way I think about this and the way I remember this is protons positive, both begin with P. Neutrons no charge are neutral. All right. And then you really just have to remember the only one you have to like outright remember is electrons with a negative. All right. All these elements, each atom, all right, we'll find them on the periodic table. Periodic tables of elements. All right, we see these in most of your science classrooms. An element is a pure form of a substance only made up of one type of atom. So if I would say helium, it is only made up of helium atoms. Okay, helium has an atomic number of dose, all right, and an atomic mass of 2. So what that means, and you'll talk more about this. Got 2 protons, 2 electrons, and 2 neutrons. Okay, so you'll talk more about this in chemistry. We'll lead down this road in chemistry, but that is how we read a periodic table. So the attraction of elements often lead to bonding, and that's more what we're worried about as opposed to just outright elements and all that. Because once we start throwing a couple of these bad boys together, we end up getting compounds and things like that, which help us living organisms sustain life. Okay. So when 2 elements are attracted together, they form a bond. 2 or more elements are put together, it is called a chemical compound. Okay, so example, we got salt, NaCl, we got water. So you could also have things like chlorine gas, okay, Cl, chlorine, and then there's 2 of them. This is not a compound. This is a molecule, but not a compound. Here's our periodic table of elements. You can see it goes from all the way from our lightest to hydrogen. And they keep adding on to this kind of unknown area in section. They keep coming up with new ones. So, but you get some pretty heavy ones down there. All right, so chemical bonding. There are 2 main types of chemical bonding that we're going to talk about in this unit. We'll talk a little bit more about another one in the water unit. Okay, so we have ionic, which is made of ions. And covalent bonding, which no ions are formed, we just share electrons. It's just a little symbol for electrons, that way I don't have to write it out a million times. So in ionic bonding, we have a transfer. That's the reason this word is kind of italicized in different color, of one atom to the other, and I'll show this in a minute. And then in covalent bonding, we have a sharing of electrons, okay? So what I always say in class is ionic bonding is like, I need a quarter to buy a bag of chips. So I'm going to ask you, hey, can I have a quarter? I need to buy a bag of chips. So you have transferred money to me, but ultimately I get the chips because you gave me the money. In covalent bonding, it's like, hey, I got 50 cents, you got 50 cents. Well, why don't we split a bag of chips? All right. So here we're going to share the electrons, like the hydrogen is sharing with the oxygen here. Okay, they're sharing these electrons. More or less, those electrons are racing around the outside of these bad boys all over the place. Everybody gets turned, all that kind of good stuff. Here we have sodium, which has this one extra electron on the outside, and chlorine, which is only missing one electron. So what sodium does, he's like, here, take this. I'm good. I don't need it. All right. You take that. Electrons being negative means that this portion becomes a negative charge. This portion becomes a positive charge. And they're kind of drawn together essentially like a magnet, for lack of a better way to put it. All right. So two main types of bonding we'll talk about is covalent and ionic. Now, we will talk a little bit briefly about hydrogen bonding. We're going to more leave this to, we'll talk more about this and the properties of this when we get to water. But for right now, we're going to throw hydrogen bonding in here too. All right, so if you remember from the last slide, hydrogen bonding, or covalent bonding, I'm sorry, is the sharing of electrons, okay? Now, hydrogen's atomic number is 1 and its mass is 1. We have oxygen here at atomic number of 8, but a mass of 16. So the oxygen portion is 16 times larger than hydrogen, okay? So what does that mean for the electrons? It means it is going to share the electrons unevenly. So this is 16 times larger, so it's going to get a bigger share or get to keep the electrons for longer, okay? That means it is going to create a slightly negative, since electrons are negative, a slightly negative end, a slightly positive end on this side, okay? Now, what that does is if we have a big old glass of water, or even if you have a small glass of water, all right, every single atom, or it's not atom, sorry, every single compound of water, molecule of water, is going to have the same thing going on. A little bit of negative, a little bit of positive. And this means slightly. The symbol means slightly. Slightly positive. So this slightly positive end is going to be attracted to this slightly negative end. They're going to form what we call hydrogen bonding. The reason we call it hydrogen bonding, it is usually at a hydrogen is where it happens. All right, so we're going to stop there. Just leave it there for the base biochem and bonding. We'll get into molecules versus compounds in the next video. Y'all have a great day.